Hello, this is Chris. We're taking a look at questions 25 and 26 here in section 4 of SAT Practice Test 4. So for question 25, we see these two functions, f of x and g of x. And it says the polynomials f of x and g of x are defined above. Which of the following polynomials is divisible by 2x plus 3? And then we see here for our answer choices, H, P, R, and S of x, where we do different manipulations with these functions. We add them together, or for some of them we multiply by a coefficient times one of the functions. So this is going to be pretty messy if we have to do polynomial division, which we could do, but there's going to be a lot of complex algebra involved in combining these functions together algebraically and multiplying or distributing by coefficients. If you had to multiply like 2 times an entire thing or 3 times an entire thing, it's going to be a little bit of time consuming and quite difficult math. So let's see if there's another way. And just like with a lot of questions, whenever we see variables among our answer choices, it's a good indication that we can use this strategy PAM, which stands for pick, answer, match. So we could pick a value for x and then plug it into each of these functions and get numerical results that we can work with a little bit more easily. So let's try that. Let's see what we want to pick for x on this. And to keep the math easy, let's try something small. Let's try x is 1. And then let's see what these answers would come out to. So if you plug in a 1, you'd have 2 plus 6, which is 8 plus 4, that's 12. And if you plug in a 1 to this function, you'd have 1 plus 3, which is 4 plus 2, which is 6. All right, so f of 1 would be 12, and g of 1 would be 6. And now, to figure out what's divisible by 2x plus 3, again, we're still using 1. So when we go to answer this question, we're going to get numbers for everything. 2 times 1 is 2, plus 3 is 5. So basically, this question translates into, like, which of these, the correct answer, is going to be just anything divisible by 5. All right. Well, now let's take a look at each of our answer choices. So we said that f of 1 was 12, and I know it's written above, but I'm just going to rewrite it down here in case we move the screen around a little bit. And g of 1 is 6. Okay. So here, for answer choice A, if you're plugging in a 1 for x for each of these, 1, 1, 1, 1, 1, 1, 1, 1, 1, everywhere we see an x, then let's see what we get. So here, h of 1 would be f of 1 plus g of 1. Well, that's 12 plus 6, which is going to come out to 18. P of 1 is f of 1 plus 3 times g of 1. So that would be 12 plus, and then this would be 3 times 6. So that's 12 plus 18. That would be 30. So A we know doesn't work. B seems to work. Let's make sure that that's the only one that works before you pick it. Let's make sure we test C and D. For C, we'd have 2 times 12 plus 3 times 6. So that would be 24 plus 18. That's 42. That's not divisible by 5. So far, answer choice B was the only one that was divisible by 5 as we go through our matching process to see what gives us something divisible by this value. And then for D, we have 3 times 12 plus 2 times 6. So that's 36 plus 12. That'll be 48. So that's not divisible by 5 either, and our correct answer choice on number 25 is answer choice B. So again, if you're not familiar with this PAM, with this pick, answer, match process, definitely take a look at some of our other videos where we cover it, but it's hugely, hugely beneficial in making a really difficult algebra question a lot easier by working with concrete numbers. All right, let's take a look at 26. It says let x and y be numbers such that negative y is less than x is less than y. Which of the following must be true? And we have 3 Roman numerals here. Absolute value of x is less than y, x is greater than 0, and y is greater than 0. So let's test out some values and see what this relationship might look like. So here, let's do maybe like x is 2 and maybe y is 3. And then so negative y would be negative 3. Okay, so that works. So those are okay values. So let's see how that works for these Roman numerals. If x is 2, you have absolute value of 2 is less than 3. And that's true for that one. And then x is greater than 0. Well, that's true. And then y is greater than 0. Well, that's true with what we picked. So all of these work. Does that mean our answer choice is D? Not yet. So be careful. We have to make sure when we have a variety of numbers that could be used with a Roman numeral question, that just because something works with one set of numbers doesn't automatically mean that it will always work. And the key wording here that lets you know you have to check every possibility is must be true. So if they said could be true, then if you find something that works, you don't have to retest it and see if there's another option that would not work. All we care about is, hey, if it works, and that's good enough for that when it could be true. But this is must be true. So that means it has to be true for any set of values, but it does have to be values that fulfill this relationship that they outline in the question. So you can't pick, for example, x is negative 10 and then y is positive 5, because that wouldn't make this expression true. Okay, so here for this inequality to be true, let's try some other values. Well, let's change up y a little bit. Let's say y is 1, and so this would be negative 1. And then let's say x is 0. Okay, so that would still work, right? We have x in between these y values. But the reason I changed these up a little bit is because I wanted to test out maybe changing any of these Roman numerals. So for example, I saw here that x is greater than 0. So I said, well, what if I made x 0 on that? Just to test that out. Just to see if there was, something that, I could do that would change up my answer to any of these. And so for the first one, absolute value of 0 is less than 1. Well, that's still true. But here, x is greater than 0. Well, no, x is equal to 0 on this one. Roman numeral 2 is not true anymore, which means if it's not true once, then you can eliminate it as a must-be-true scenario, which means you can eliminate any answer choice that has a Roman numeral 2 in it. And now we're between A and C. And let's check Roman numeral 3. Y is greater than 0. Yep, well, y is greater than 0 here. All right, so now let's try. We know Roman numeral 1 is true. So again, we're done evaluating that. That one, it's in both of our remaining answer choices. So all we really care about is down here, Roman numeral 3. Is there any value that we could pick where y would be a negative? Well, let's try. So if I tried y as negative 2, then regardless of what I picked for x, but over here, the negative of negative 2 would be a positive 2. And I would be left with, again, you could leave a blank in the middle for x, doesn't even matter, but I'd be left with a positive number being less than a negative number, which isn't possible. So there's no way that we could make y a negative value. And let's try maybe making y 0 then. What if y is 0? So if that's 0, well then that's also 0. But then x would be 0. But notice these inequalities, it's less than. Less than. It's not less than or equal to. So they couldn't all be zeros and they couldn't be equal to each other. So 0 wouldn't work. So if y can't be a 0 and it can't be a negative, well, guess what? Then we know categorically that Roman numeral 3 has to be true every time, and our correct answer is C. So the numbers might seem like they're not very big and not that hard to play with here, but conceptually, 26 is a tricky question because it does require us to be ultra